Hi everyone, today we're going through lesson 115, graphing cubic functions. On this chart here, you see three of the kinds of functions we've gone through this year. We've gone through linear, quadratic, cubic. We've also gone through absolute value functions. We've also gone through, last class period, we went through square root functions. But these are the three main ones. And you can see how the shapes of the graphs vary. You have linear, a straight line. You got quadratic, a V or a U-shaped, so a parabola. And then you have cubic, you have like a squiggly line. But if you notice that the degree here, remember, is the greatest exponent that you have in any of the variables. So for linear, you have a degree of 1, which means the most x-intercepts you can have is 1. The quadratic has a degree of 2 because you have an x squared. And the most times it can cross the x-axis is twice. And then the one that we're going through today is cubic. So you're going to have an x cubed in your function. And the most times this can have cross the x-axis would be 3. And then like how does the end of the graph look? If you look here for a linear, the ends go in opposite directions. For a quadratic, they both go in the same direction, and in cubic, they go in opposite directions. So you can always refer back to the chart for details on how some of these functions differ. Let's take a look at an example here. Graph this cubic function. Okay, so this one has an x cubed in it. You can see there's two tables. They're graphing y equals x cubed and y equals a negative x cubed. They use the exact same x values, and you get pretty much the same y values. The only difference is the y's are the opposites. Okay, when you have the y equals x cubed, your y's are all going to be negatives and then positive. When then x is a negative, it just flips. So now when your x's are negative, your y's are positive. And when your y's are positive, or your x's are positive, your y's are negative. And so you can see that the two graphs, they're flipped from one side to the other. We'll take a look at one example where we're going to put the values in, we're going to graph it. So it says evaluate the function y equals 2x cubed for x is negative 2, negative 1, 0, 1, and 2, and then graph the function. So if I put a negative 2 in for x, a negative 2 cubed is a negative 8. A negative 8 times 2 is a negative 16. If I put a negative 1 in, negative 1 cubed is negative 1. Negative 1 times 2 is negative 2. Put a 0 in. 0 cubed is 0. 0 times 2 is 0. Put a 1 in. 1 cubed is 1. 1 times 2 is 2. Put a 2 in. 2 cubed is 8. 8 times 2 is 16. Now that we have our table created, we can now graph these on our coordinate plane. Since the biggest number is 16, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have enough there. So if I count by 2, so 2, 4, 6, 8, 10, 12, 14, 16, this will give me the 16 here. 2, 4, 6, 8, 10, 12, 14, 16. This will give me a negative 16 here. And then we'll just count by ones for our x-axis. Okay, so now let's plot our points down. We have negative 2 and negative 16, so negative 2 up to negative 6, down to negative 16. So that would be right here. Then we have negative 1 and negative 2, so negative 1, negative 2 would be here. Then we have 0, 0. This will be right here. Then we have 1, 2. So 1, 2 would be here. And then 2, 16 would be all the way up here. So now you can kind of see my graph forming. So now if I take my pen and then we just connect the points, you can see that it is a curves more like a stretched out curve here. But you can see that it does cross the origin, and you have a curve on the upper end and you have a curve on the lower end. That would be an example of a cubic function. This next one, we're going to choose the values to put in for x. So you can choose any one that you want, but you should choose positives and negatives. So let's do a 2, 1, 0, negative 1, negative 2. If I put 2 in for x, 2 cubed is 8, 8 plus 1 is 9. Put a 1 in, 1 cubed is 1, 1 plus 1 is 2. Put a 0 in, 0 cubed is 0, plus 1 is 1. Negative 1 cubed is negative 1. Negative 1 plus 1 is 0. And negative 2 cubed is negative 8. Negative 8 plus 1 is negative 7. So now that we have our points here, let's graph them. I should be able to count by 1, so these are all counted by 1. So I go with 2, positive 9. So here's 2. Positive 9 would be up here. So 1 and 2. So 1 and 2 would be here. 0 and 1 would be here. Negative 1 and 0 would be here. Actually, not there. Negative 1 and 0 would be here. And then negative 2 and negative 7. Here's your points there. So now you can see my curve here. I'll now draw my graph. Come down, curves over here. Here's my graph. This one, you notice, does not cross the origin. It's up 1 compared to the parent function. Example 2a, solving cubic equations by graphing. So here we need to find out what are the x values going to be. So what are our zeros? So here they have an example here. You would graph that first. So you would come up with a table, you would graph it, and then find out what is this point right here? Where does it cross the x-axis? And in this case, you can add 1 to both sides, and then so if you were to add 1 to both sides, you'd have make that equal to 0. So you add 1. So you have 1 equals x cubed. Find the cube roots. If you want to do a cube, you find the cube roots of both sides, and that would give you an answer of 1. And you can see that it crosses there at 1. Okay, so let's look at an example ourselves. This one you can also use for as example. They go step by step on how to solve one of those. Here you can see that it's not exactly a whole number, so you would do the same thing like I just did, everything to one side, and then find the cube root. So let's try this one ourselves. Solve 0 equals x cubed plus 2 by graphing and solve for x. So if I put a negative 2 in, negative 2 cubed is negative 8. Negative 8 plus 2 is a negative 6. Negative 1 cubed is negative 1. Negative 1 plus 2 is 1. Put a 0 in. 0 cubed is 0 plus 2 is 2. 1 cubed is 1 plus 2 is 3. 2 cubed is 8 plus 2 is 10. Again, I do have 10 marks on each direction, so I should be able to count by ones here. So let's plot our points. So negative 2 and negative 6. It would be here. Negative 1 and 1. Negative 1 up 1 here. 0, 2 here. And then 1, 3 would be here. And then 2, 10 would be all the way up here. Now I grab a different color to draw my graph. Comes down, does a little curve there. Now you can see it's more than I have to figure out where does it cross the x-axis. So I'm going to take 0 equals x cubed plus 2. I need to get the x cubed by itself, so I'm going to subtract 2 on both sides. So now I have a negative 2 equals x cubed. To undo a cube, find the cube root of both sides, cube root. Now before somebody might say, oh, I thought you couldn't find the square root of a negative number. We can't. This is not a square root. This is a cube root. So what do you multiply by itself 3 times to get that number? So if I get my calculator out, turn on, I'm going to do the cube root. So I need to hit the math button. Here, cube root is number 4. Number 4, cube root of a negative 2. It gives us an answer of a negative 1.25. 992105. So to be, you can round it to the nearest tenth, but if you want to be a little more accurate, round it to the nearest hundredth. So I would make this a negative 1.26. So x is about a negative 1.26. You can try this next one yourself for extra practice, as well as 2e. And we'll do 2f for one more example here. So first off, we need to get this so it's equal 0. So I need to subtract 3 on both sides. So I have a negative x cubed plus 5. Now I can make this equal 0. Now I can put a negative 2 in. Negative 2 cubed is negative 8. Negative 8 is a positive 8. Positive 8 plus 5 is 13. Put a negative 1 in. Negative 1 cubed is negative 1 times negative is positive 1. 1 plus 5 is 6. 0 cubed is 0 plus 5 is 5. 1 cubed is 1 times a negative is negative 1 plus 5 is 4. 2 cubed is 8 times a negative is negative 8 plus 5 is a negative 3. Now I have my points here. Now I can graph them. I'm just going to count my 2's again. 2, 4, 6, 8, 10, 12. So this is 12. 14 is here. And then we'll count by 1's going on the x-axis. So this is 1, this is negative 1. So now let's plot our points. We have negative 2 and 13. So negative 2 up to 13, that's in the middle here. Negative 1 and 6, so negative 1, 2, 4, 6 would be here. And again, 0, 5, so 0, 5 would be here. And then 1, 4 would be here. Then we do 2, negative 3, so 2, negative 3 would be right here, like that red. So now you can see my curve going. Draw down. Here's my graph. Can't quite tell where it crosses the x-axis, so I'm going to solve for x here. So I need to subtract 5 on both sides. So now I have a negative x cubed equals a negative 5. Divide by a negative 1 to get rid of the negative. So now I have x cubed equals a positive 5. Find the cubed root of both sides. The cube root, estimate that one, so we'll grab our calculators out again. We'll hit the math button, hit number 4, cube root of 5, enter. So give us 1.709975947. So we would round that to the nearest hundredth, which would be about 1.71. Example 3, solve on graphing calculator. So here we're going to do a sample one here. I'll take my calculator out again. We're going to do this example right here so you can see how to solve this one. So we're going to hit the y equals button. We need to type in this equation, but first we need to get everything to one side. So I'm just going to make this negative 2x squared, bring it to the other side. So I'm going to hit parentheses 1 divided by 2, and parentheses, this is my x. Hit the caret symbol for the cube. And then we're going to be plus 2x squared minus 1. Now if I hit graph, you can see my graph here, like the one that you see in the picture here. Now we need to find where does it cross the x-axis, and it crosses in 3 places here. So to do this, we're just going to hit this, the second trace, and we want to find the 0. So I'm going to hit number 2. I want to find the left bound, so I'm going to go all the way to the other side. I'm going to go right below. So I'm right below, so y is negative, hit enter. Go right above, hit enter, and enter a third time. And it says when y is 1e to the negative 12th, so that means it's very, very close to 0. You would have a negative 3.86, so if you would round it to the nearest tenth, it would be a negative 3.9, and you can see that's what they have here. Or if you did to the nearest hundredth, which is a little more accurate, it would be negative 3.87, which is what they had here. To find the next one, hit second trace, hit number 2 again. We want to find this one. So I'm going to hit the right arrow button. I'm going to go right above it, so I know I'm above the x-axis because this is positive. Hit enter, go right below. Now it's a negative, hit enter a third time. Guess when y is 0, x is a negative 0.789. So that would be to the nearest hundredth, negative 0.79. And that's what they have here. And then the third one, hit second trace, number 2 again. I'm going to go all the way to the other side here. So this is a negative, hit enter, go above, hit enter a third time. It says when y is 0, x is a negative 0.655, so that's a positive 0.66, which is what they had here. So that's just another way of doing it on your graphing calculator to find the zeros. And let's get to an application problem. A cube of pure gold weighing 100 pounds would have a volume of about 143 cubic inches. Use a graphing calculator to estimate the side length of a 100-pound cubic of gold. So we're going to get our graphing calculator out again. Need to hit the y equals button. I'm going to clear this. And so since I'm dealing with cubic inches, that means I'm finding volume. So my equation is going to be y equals x cubed. So x raised to the third power. Now if I were to graph this, you can see my graph here. But since I'm trying to find 100 pound, but I have to go all the way to 143. This isn't going to show me where 143. So I need to change some things on my window. So I'm going to change this. So my minimum, my x, we're going to make this 0. The max, we'll make this 12. And then the minimum for the y, we'll make the y minimum as 0. And the max, we'll make this 200. Now if I graph it, here you can see my graph here. We want to find out where does it get to 143. If I hit the trace button, I'm right at when x is 6, the y is 216. So that's 216 cubic inches. I need to keep going down until I get to about 143. But here I have about 143.3, so x would be 5.23. So I would say it would be about 5.23 inches. You could also do this without a graphing calculator. You would have y equals x cubed, and if x is the is the volume, I would say, actually y is the volume. So if I have v equals x cubed, I put in the volume 143 equals x cubed, where sides cubed. I need to find the cube root of that. The cube root of 143. If I come back to my graphing calculator, I can hit the math button, hit number 4. I'm going to clear that. Hit the math, number 4, cube root of 143. Hit enter, 5.229. So if I round to the nearest hundredth, that is 5.23. So that's just another way of finding cube root functions on your graphing calculator. You may try this next one yourself for extra practice. Your assignment then for next time would be lesson 115, numbers 3 to 6, 8 and 9, 11 to 12, 20 to 21.